Welcome to Guide You Mathematics. Today I will be looking at forming a group from a committee, which is also a permutation type of problem. And I'm going to look at this as a permutation, and I'm going to look at a different strategy for approaching a committee question like this. So we have 4 members from a 10-member research committee are randomly selected to serve as research head, research assistant, research analyst, and research coffee preparer, probably the most important job there. How many different committee structures are possible? So we want coffee preparer, analyst, assistant, and head. So this is going to be a permutation. And the reason it's a permutation is because a permutation is the number of ways that we can order our objects from n objects. So if we have 10 people to pick from, we want to take a group of 4 of them and give each of those people a specific task. So as a permutation. Now the first way we could look at this problem without it being a permutation is for the first job that I want to assign. So the first job I want to assign is a research head. How many people do I have to pick from for the first job? I have 10 people. And repetition is not allowed because each person is getting a specific job. After they get assigned that job, they're out of the picture for the next job. So if I assign someone for the research head, then that means I have 9 people left over for the next job, which is research assistant. And then I have 8 people left for the research analyst, leaving me with 7 people to be the coffee preparer. So I would just do 10 times 9 times 8 times 7 using the multiplication rule of counting. And that would give me 5,040 ways that we can structure these 4 people being picked for these 4 jobs from a group of 10. So that's using the multiplication rule of accounting without repetition because we can't repeat jobs. Another way of looking at this is as a permutation. So 10 people, permutation of 4. And you could do the formula. I'm most of the time, most classes that you'll take with statistics, you might do the formula once or twice, and I don't want this video to be an entire lesson about the formula for permutation, how you manipulate it and everything. That's a separate video, but most of the time, if you're taking the stats class, you'll just use your calculator, the permutation function on your calculator. So you just use that, and you would still get, so 10 permutation of 4 in your calculator would give you 5,040 different committee structures possible for this. So permutation, it's important to know here that order matters. That's probably one of the most important aspects of the permutation in comparison to a combination. The order matters. Another classic example of a permutation is, let's turn this into a race. 10 people running a race. And we want to know how many ways can the top 3 finish. So 10 people in a race, how many ways can the top 3 finish? That is a permutation because order matters. The first person that finishes is the first person. They are in first place. Second person is the second person, so they are in second place. Their specific roles for that place. Like you're getting a certain job if you're in first place, second place, third place. Like you are in the first place spot. First place and third place are not the same. So order matters, so that would be a permutation. So 10 permutation of 3, which is going to be 720. So permutation, order matters when we're pulling groups of people from a bigger group. So here we wanted to pull 4 people from a group of 10. So that's a permutation. Or you could use this multiplication rule of counting, and you could have done the same thing for this other example I just made. 10 people run a race, top 3, 10 times 9 times 8 is going to give you 720. So I hope this helps with permutations. If you like this content, please hit that subscribe button, and thank you so much for watching.